Hi, this is Mr. Word, and this is the Geometry Do Now 35.1 video key. So I'll be the key. So there's some new definitions and postulates for you to check out. So let's take a moment on those. A couple of new words, a secant and a tangent. So a secant is a line that intersects a circle at exactly 2 points. A secant will have an external and an internal portion. A tangent is a line that intersects a circle or actually other curves at exactly 1 point. Okay, so a tangent will intersect a circle at exactly 1 point. And that point is known as the point of tangency or the point of contact. So right there, right there, right there. Okay, and this suggests some postulates about tangents. A tangent line is perpendicular to a radius drawn at the point of contact. So if you have a tangent line, and you have a radius, you have a right angle that can be very useful when working out triangle-y proofs. If a line is perpendicular to a radius at its outer endpoint, then it is tangent to the circle. So those are a couple of postulates you'll need. Okay, so here we are going to try to prove Theorem 76 and use circle O and the given information to prove that these two tangent segments, xp and yp, or px and py, are congruent. That is Theorem 76, which says that if two tangents are drawn to a circle from an external point, we'll call that P, then those segments are congruent. All right, well, there are some things that we should know in this situation. One is the postulate tells us that's a right angle, and that is a right angle. Once you have right triangles, and you see some right triangles going on here, the possibility of hypotenuse leg comes up. This side and this side here, this OY and OX are both congruent because they're radii. And OP is congruent to itself because it is itself the reflexive property. So we can prove that triangle OYP and OXP are congruent. And then with that, we can prove by Kappa-Kadika that side PX and PY are congruent. So these two tangent segments, which come from a common external point and are tangent to the same circle, are going to be congruent. Okay. This leg and Kappa-Kadika. Okay. So there's more to it, of course. That's not really a full proof. I'm just leaving that as a note to myself to remind myself what I said. Now, if you're writing a proof, you need to write more than that. Now, here we have xy. It's a common internal tangent. That means it is common as a tangent to two circles, and it's between them. That's what internal means. Okay, so xy is that. Two circles, a common internal tangent, circles P and Q at x and y. We know that xs is a tangent to circle P at S, and YT is a tangent to circle Q at T. We want to conclude that XS and YT are congruent. Well, if we go back to Theorem 76, right here, which says if you have two tangents that are to the same circle that come from a common point, then you have congruent tangent segments. So let's consider these. So XS and XY are two tangents to circle P, which come from an external point, X. Also, YT and YX are tangents to circle Q and come from a common point, Y, which means that XY and YT are congruent. So we know that this segment and this segment are congruent. And we also know that this segment and this segment are congruent based on Theorem 76. So if this is congruent to this and this is congruent to this, then we can say that S Sx and Yt are congruent, or Xs and Yt are congruent. Okay, so theorem 76 for the win. And of course, that is not a complete proof. I've just laid out the strategy for you. I'm just writing this note here to remind myself the basic approach. Theorem 76 and the transitive property. I hope that was helpful.